to start with the calculator part so that we can kind of then just be done with the calculators. So can you flip to number 14? We're going to just do the calculator part first. Also because they're easier, and I wanted to start with something sort of inviting, like instead of the more difficult questions. All right, a car uses gas at the rate of that thing, gallons per week. How much gas is used from 0 to 3 weeks? What are you going to do? Integral 0 to 3 of that thing. Everybody practice typing it. As a heads up, that's basically what this whole page is. That's pretty much what these questions are. So this looks like a longer test than it kind of is, because that's a big bulk of it is this, and there's not really much to it. Let me share my screen. You're going to type INT. Yes, you can use T. T over 2. And this is, I wanted you guys to practice typing them and not just watch me type it, because it's a skill you're going to need to have. I got 38.939. So looking at this one, a swimming pool is filled at a rate of that gallons per minute. Now this one has something extra. There were 60 gallons to begin with. That is called a what? Initial condition. Good. Okay, so it's going to be 60 plus integral what? 0 to 30. Beautiful. R of t dt. So everybody go ahead and give that a type. It's not right on mine. Can somebody let me know if they got that as well? That's what you got? Okay, then it must be right. All right. 2,897.887. That is what you guys got? 2897. Okay. Yeah.
On that, then will we have to, will they just know that we plugged in like,
Yes. Well, and these would be multiple choice anyway, but I recommend writing, but even for free response, I recommend writing R of T. 2 reasons. Number 1, the exam's timed. Writing this is time consuming. Number 2, if you do a copy error, it's wrong. So write R of T. But it wouldn't be wrong if you rewrote that, as long as you did it correctly. It doesn't matter either way. All right, a swimming pool is filled at a rate of this much gallons per minute. There were 20 to start with, but water is also leaking out. It's a rate in, rate out. I want to see if you guys can set it up. So it's going to be what? 20 plus integral 0 to 30 R of t, and I heard someone say minus, good job, W of t dt. All right, and you would need parentheses around like that whole thing, like give the whole thing a hug. All right, good job, you guys got it set up. Let's go ahead and type it in. If you type just the letters PI, pi will show up in there. If that is helpful to you. They are not going to give you nice functions. It will be a mess. That's why we're practicing this. It will be yucky. They're not going to give you something nice. You know, College Board. So, and I will go over this at length, like exactly how the test is gonna go, but you will have a calculator, multiple choice and a non-calculator multiple choice. And the way it shakes out is you get more minutes per question on calculator ones because they understand that the button pushing takes time. Did anyone get the same thing as me? All right, I will be right with you over there. 58.978. While I go answer this question, I want you guys to try the next one. Oh, it's not the party problem. All right, how'd you set it up? 30, good. Plus, wait, hold on. There's initially 30. They're leaving. They're leaving, so we want to subtract integral 0 to 2 r of t dt. Good. Okay, let's go ahead and throw that in there. No, hold on. If you put plus, you should catch it because your answer will be bigger than 30. And you should go, oh, if there were 30 to start with and people are, remember the M&M question?
Yeah.
And I was like, oh, that wouldn't make sense if we had more M&Ms than we started with because we're eating them. As long as you are paying attention, you should be okay. All right, so what is this? 30 minus, I know paying attention is a big ask there. Can you please calm down? All right, I got 24. All right, now we're not going to decimal point a person, so that's just 24. Did some of you decimal point a person?
Oh, and this will be multiple choice.
Yeah, you can't mess it up. It's multiple choice. All right. A particle's velocity is given by that thing, initial position at time 0, but is it always starting at time 0? No, it's what you practice that with delta math. It's whatever time they give you. Is 7. What is the total distance traveled? Do you need this just to find total distance? No, thank you. Total distance will be integral when to when? 0 to 6. Thank you. Why is it absolute value? Total distance. Now hold on. I want to set up the other one too before we go to the calculator. What is the displacement from 0 to 6? Well, that's integral 0 to 6 just without the absolute value. Did we use the initial position at all? No. It is there. Why? To try to confuse you and trick you, because when I said integral what to what, half of you said 0 to 7. That's why they did that. And I guarantee one of the wrong answers would be that. Okay. Which one of these is going to be the larger number? Top, yeah, that one with the absolute value. So let me make a suggestion. Type the bottom one first, because you can just throw the absolute value around it afterwards, and then you won't have to type the whole thing twice. So just do part B first. I'm going to show you. There, I got 732. If you don't mind watching, I'll show you how to just stop what you're doing and watch for a second. You're just going to highlight the stuff inside. Come down here into your menu and click on the absolute value and it'll throw that in there. Now it's not much bigger, but it is bigger. It kind of depends on the function. I guess they could actually come out to the exact same thing if the area was all positive. Do you know what I'm saying? It's kind of like the absolute value of 3 is 3. I guess they could be equal. Hadn't really thought of that before. Equal, or this one needs to be bigger. All right, so 732.198. You highlight it, come down in here in your menu and hit the absolute value button.
If you were just gonna,
you know, I'm not sure if it will take that. I kind of don't think so. No, it doesn't. Nah, it won't do that. Okay, we're gonna go do the free response calculator one. All right. Oh, I can see the picture through here. Oranges are put on a shelf by employees and customers are removing them to purchase. I modeled this after the one they did a couple of years ago that was bananas. It's the same thing except bananas. All right. Let's read. There are 50 to start with. That's your initial condition. when our story begins at time 0, that's when the store opens, they get removed at 12 oranges per hour. That's your rate out. And then this graph right here, R of T, which if you want to label that R of T, that's this guy, is the rate at which they're put on the shelf. So you start with 50, R of T is your rate in, 12 is your rate out. We all together? So far? Okay. You're gonna need these areas. Let's go ahead and slice it up and find them. What's this first shape? A trapezoid, but it's on its side. All right. 1/2 times the height, which is just 1. And then what? Yeah, base 1, base 2. That's 16 plus 12. So what is that? Half of 28, so 14. All right, another trapezoid. Yay. 1/2 times 1. And then 12 plus 6. So what does that shake out to? 9. Another one. 1/2, the height is 2. And then your bases are 6 plus 4. You're really good at trapezoids. So the 1/2 and the 2 cancel. That would just be 10. And then a triangle. So 1/2 base times height. Base is 3, height is 4. So half of 12, which is 6. Okay, cool. We found all of that. How many oranges are put on the shelf from 0 to 2? Don't skip the setup. You get a point for the setup, like what we just did on the other side of the paper. What's your setup? Integral. 0 to 2, R of T dt. Why do we not need any of the other information? We don't need the 50. We don't need the rate out. All it asks is how many got put out from 0 to 2. That's it. Okay, so from 0 to 2 is this much. So how many oranges got put on the shelf? 23. Be a 2-point problem, a point for the setup, a point for the answer. Letter B, is the amount of oranges on the shelf increasing or decreasing between time 4 and 5? Justify your answer. You compare the rate in with the rate out. If the rate in is bigger than the rate out, then the amount of whatever you're talking about is increasing. If the rate out is greater than the rate in, then your amount is, it's very intuitive, okay? So between 4 and 5, right here, our rate in is like around here, like around 4 oranges per hour. What's the rate out? Because they told that to us. 12. So the rate out is bigger than the rate in. So good. We're going to say decreasing because, and I'm just repeating the problem here, between t equals 4 and t equals 5, 12 is greater than R of T. Or you could say R of T is less than 12. I probably should have put it that way for you. I'm sorry. You could write it the other way. Okay. You're just saying the rate out is greater than the rate in. All right, cool. That seemed like that one. Okay. Letter C, at what time is the amount of oranges on the shelf a maximum? That now they don't use the word absolute, but it means the biggest. What's your test for units? Oh my gosh, perfect. So we've got time, and then we've got oranges. I'm just going to write the word oranges for a second because we don't actually have a function for that. We're going to write one, but we don't have that yet. Who are your candidates? Endpoints, critical points. So your endpoints are 0 and 7. Critical points. This is a little tricky because we have 2 rates at the same time. So here's what my suggestion is. I'm going to take another color and it's not going to show up real great, but I'm going to do my best. What was our rate out? 12? I'm going to draw this line at 12. Pretend that's your new x-axis. Where's your critical point? You guys see that there? 1. Those are our candidates that we have to test. Is that okay?
Yeah.
That's really, why is that good? Why are we happy about that? Yeah, there's only one. I mean, it's not a very long list. Okay. So that's where your critical point is at 1. If I draw in this line at 12 where our rate out is, that's where your rate in and your rate out connect. Or you can kind of pretend that's your new x-axis and that's where the 0 is.
Oh,
Yeah, if you lose your mind, set the rate in equal to the rate out, because like oftentimes you can get a point for that. All right, so now we need to write an equation for our oranges. How many oranges do we start with? 50 plus, now we want to accumulate oranges. So it's integral from 0 to whenever r of t dt. But then oranges are being taken, so we want to do minus. It was 12 per hour. Good to say that louder.
okay.
12x, because it's 12 per hour. So that's kind of our function that we had to write. It's what you started with, plus how many went in, that's your accumulation, minus how many went out. All right, at time 0, there are 50. I'm not even going to bother walking you through plugging in 0. That's just your initial condition. You started with 50. But if you plugged in 0, do you see how it's integral 0 to 0? Precisely nothing, and then this is also 0. All right, so now let's do 1. It's going to be 50 plus, we want to integrate from 0 to 1. Look up at your graph. We found it. It was how much? From 0 to 14 minus how many got taken? 12. Good job. So that would be 52. Because only 1 hour went by
Oh,
from 0 to 1. We're still okay? All right, 7. It's going to be 50 plus. Now you want your area, your accumulation from 0 to 7. So that's the whole thing, isn't it? You get a calculator. Somebody slam that in the calculator and just add them all up. Or did you do it already? So 39. Just wanted to make sure it was right. 39 minus. Now, how can we figure out how many got taken? For 12 times 7, which is 84. Good. 5. What happened over the course of those 7 hours? Since there's only 5 left, people bought a lot of oranges that day. Do you get what I'm saying? Like, there's only 5 left on the shelf. Imagine if you went in and there was only 5 oranges. You'd be like, wow, oranges were popular today. Anyway, what was the question? I forgot what we were doing. Oh, maximum. Okay. Do you ever sometimes forget what you're doing? Like, sometimes these problems get so intricate by the end. I'm like, what did they even want? All right, maximum. So the absolute maximum is how many oranges?
1. Oh, 52.
52 oranges at time 1 hour. All right, the last one is write but do not solve an equation when all the oranges are gone. It's going to be this that we just did, set equal to 0. You start with 50, you add your accumulation, you subtract how many got taken. It's what you started with plus what you gained minus what you lost, and we're just setting it equal to 0. That is usually worth 3 points though, because it's the initial condition, it's, you know, this integral, and it's setting it equal to 0. I love those because you get a boatload of points for not really doing anything really. I'm gonna do, so that was all the calculator stuff. I'm gonna do the free response one next. Just to knock that out of the way. So we'll start with 13, but I'm gonna give you your halfway break. So for this one, what is this the graph of? It says it, it's the very first thing. I'm just checking you're reading it. F prime. That is good. That's the one that tells you everything you need to know. Got your sticky note? Got mine here. I can put it up. All right, that's fine. I've got mine. All right. Now, it also gives you the regions bounded by all of these intervals. Okay, so this first one is 15. Do you see how it just says that there? Now, it says the next one is 7, but we know that it is -7. Good job. This little, like, hill there is 2. And then this last one, and I'm going to draw the line. Where does our interval end? 8. I'm going to draw this line down to 8 here just so that I have it. That amount is 6. That is awesome. They just gave us all those numbers. Fantastic. Go us. All right. Find the x coordinate of each critical point. Does it say to justify? Does it say to write a sentence? Do we need a reason? No, literally just put the answer. I see 4 of them. What are they? -2, good job. 1, 4, and 6. Nice. That's it. Move on. Identify the critical point. So one of those, which is the location of a relative maximum, justify your answer. Your sentence starts. Oh, this one isn't g of x though. Is it f of x? Let me be really careful there. Yeah, function f. Okay. F of x has a relative maximum. Oh, wait, was it maximum? Yeah. At x equals, that's how you need to start your sentence. F of x is or f of x has. Relative maximum at which one of those that we just mentioned? Why is it 1? That is correct. At x equals 1. Because f prime goes from positive to negative there. Well, that is why I drill and drill and drill those justifications into you. So when it says justify, you're not worried about it. It's the sentence that you've written 1,000 times. Find the value of f, which is not the graph you're looking at the x coordinate identified in part B. So we need to find the value of f of 1. Now look, they actually give you 2 starting places. It's sort of like 2 initial conditions. Because they want you to choose which one you have to use. Oh, go ahead and close up. Fixed. One of them we're going to be able to use. The other one we're not. This one starts at 0. Why can I not start at 0? Yeah, I mean, I know this whole area is 15, but can I split it at 0? No. F of 4. I can start at 4. Do you see why? Now, the reason they're giving you 2 is because they're making you choose. We're going to need this one. All right. So it's going to be 3 plus integral what to what? 4 to 1. Why is it 1? Because it says find the value at the one that we found in part B. Okay. It's harder without a story. Do you know these ones that we did that all had a story with them? You all shouted them out in 1 second. The word problems are easier because they make sense. This is just random numbers. Why it's harder, all right? F prime of x dx. So it was 3 was our starting point, and then our integral begins at 4, and we're going to 1. Okay, so let's see. This is going to be 3, and then we want to go from 4 to 1. What do you think? We're going from here to here. Good, plus 7, so 10. You could leave it 3 plus 7, though, if you wanted to. All right, absolute extrema. That is your candidates test. Your candidates are all the numbers that we mentioned in part A. It's going to be a lot of them here. And then also, what other value do I have to include? Yeah. Now, -2 already was an endpoint, but the other one is 8. Now, we already found the value at 1. We already did this one. We found it is 10. All the others, you have to do 3 plus your integral from 4 to wherever, if you want to write that down. It's the exact same thing we just did in part C. You're just going to repeat it for all those other numbers. All right. So for -2, just watch me point to this. It's going to be 3 plus 7, so 10 minus 15, which would be -5. Good job. How about 4? What do you think? If you were going 3 plus integral 4 to 4, so just 3, because your integral doesn't take you anywhere. All right, 3 plus integral from 4 to 6. So 3 plus 2, 5, and then going all the way to 8. So it would be 3 plus 2 plus 6. 11. Good job. Okay. Absolute maximum is what? (11) at x equals 8. Absolute minimum is -5. Good. At x equals -2. All right, let me pull out my sticky note. On what intervals is the function, not the graph you're looking at, decreasing and concave up? Just watch, the sticky note will do this for you. Decreasing and concave up. That's where the graph we are looking at is negative, that means below sea level, and increasing. So where is this graph below sea level and increasing? Where to where? Yep, 2 to 4. So 2 to 4, because f prime is negative and increasing there. Your sticky note does it for you. I'm going to let you use your sticky note. But you can't write anything else on it. It has to just be the pure sticky note. Do you understand what I'm saying there? It's not like that note card you get in physics where you can write tiny and fit as much stuff on there as you want. Like it can just be this. Okay. Explain why there must be a value of c 0 to 4 such that f of c equals 3.5. This was on the last test, and I think the one before that as well. What are we gonna have to say? Since, oh, good, it is intermediate value theorem. We're gonna say since f of x is what? Differentiable, it is continuous. It's gonna say it's differentiable in the problem. If you look back up there, I think it says twice differentiable. All right, since function is differentiable, it is continuous, and we have to say 3.5 is between f of 0 and f of 4, which is it? I mean, let's go check. F of 0 is 4, f of 4 is 3. Is 3.5 in between those? Yeah, I mean, they're going to make it work, right? And then what do? You say those two things, and then you restate the problem. There must be a value c blah, blah, blah. Just recopy it. There must be a value c for 0 to 4 such that, which makes you sound really smart, f of c equals 3.5 by IVT. So differentiable continuous between, restate the problem. These two are ones we haven't done in a little while. I'm gonna let you look at this one and see if you can. I bet you if I wait you out, you'll remember what this is, what rule this is. Good, L'Hopital's rule. What you have to do to get all the points is you have to state that the limit for the numerator is 0 and the limit for the denominator is 0. And they are, but I'll take you through that. Hold on a sec. Well, this one's obviously 0. 7 times 0 is 0. What is f of 0, though? Because they tell it to you. What's f of 0? 4, and then 4 minus 4 is 0. That's worth a point. Writing those two separately is worth a point. It's a lot of just recopying, okay? Then you get a point for restating the problem. Hey, Ms. Cole, looks like you just rewrote the problem. Sure did. And linking that to the derivatives. You have to link them together. That's where you actually really do need an equal sign. So, oh, wait, go ahead.
Plus.
Yes, because, oh, sorry, I missed it there. Thank you. So what is your derivative of this numerator? F prime. What happened to the 4? Gone. What's the derivative of your denominator? 7. So writing these is worth a point, linking these together is worth a point, and then the third point is your answer. F prime is the graph you have. Plug in 0. What's f prime of 0? Just look at your graph. What's your point at 0? 7? Over 7, which is 1. Yay. Good, you guys handled that nicely. All right, last one of these. Find g prime of 4. All right, you're going to find g prime of x, and then you're going to plug in 4. This is throwback to derivative rules. What rule do you need for that one? Chain rule. Good job. You're going to be okay. You're going to do what with this 3? Yeah, and then it's going to drop to a 2, and then a chain rule dot. And you're going to chain on the derivative of the inside, which is f prime. Sometimes that's worth 2. And then a point for your answer. I don't remember what it is on this one. I have to look back at it. Now we're going to plug in 4. What's f of 4? They have to have either told you or given you a way to find it. I think this one they just flat out tell you. Can you look back? What's f of 4? 3. And then f prime of 4, they have to have either just flat out handed it to you or given you a way to find it. And that is, oh, good. Why is that 0? You guys are all correct. Yep. So the whole thing actually equals 0, which is kind of weird, but. All right, sweet. Let's go back and do the multiple choice ones. I already gave you a break, so I'm going to press through this. We're doing well on time. What's up? Well, sure. But we got to get through this. All right, this is like your quiz 2.0. Derivative of 3x, 3, and then you're just going to take 3x and plug it in. Now, they're going to simplify because it's multiple choice. If you take 3x and square it, 9x squared. So number 2 is almost the exact same thing. They're just throwing a lot of weird vocabulary at you. For y equals, all of this mess, find dy dx. It just means find the derivative. What happens to the 2? That's gone. So now we're doing the exact same thing we did in this problem. What's your derivative of 4x? 4, and then just take the 4x and plug it in. Now again, they're going to simplify this. If you cube 4, does anyone remember 4 cubed? 64, good. 4 cubed is 64. 4 times 4 times 4. And then it says state the initial condition. Now, that means y of something equals something. It's not always 0. Remember how your accumulation can start wherever? You want this to turn out to be 2. Where did I get that from? Why did we want that to be 2? That's the number out front. So what does x have to be for all of this to just go away so that it's just 2? What number would x have to be? Why would it have to be 1? Because then that would make this 4 to 4 and it would go away and you would just get 2. You will have choices though. You won't have to come up with that on your own. I just don't put choices on the review. Do you understand why this is 2? Matches that? That would have to be 1 because it would make it 4 to 4. Anyway, it'll be multiple choice. I believe in you. You'll be able to pick the answer out of the choices given.
Why did you say it's 2? Because it's 2 plus. Why didn't you line?
So this is indicating that your accumulation begins at 1 instead of 0 or someplace else. Like that. Or you have the 0.1 comma 2 on the graph. Does that help? That's better? Okay. All right, let your function be this. Oh, an equation. What 2 things do you need for an equation? Point and a slip. All right, it's pi over 6 comma. Oh, we get to do some unit circle. If you plug in pi over 6 here, your integral from pi over 6 to pi over 6 is precisely nothing. Now we're going to get our derivative. You just take x and plug it in. It's exactly what we did in question 1 and 2. So it's just sine of x. And to get your slope, you're going to plug pi over 6 into that. I'm going to just throw it out there and see what I get. Does anyone know sine of pi over 6? It's not 0 or 1. Good job. What's the other option? Square root of 3 over 2. Okay. So this is your point. That's your slope. You're just going to put it all together. Y minus 0 equals a half x minus pi over 6. It's just right here. If you do the derivative of this, it's just that. You're fine. There's a lot of stuff written on this paper. It's intimidating the symbols that you're learning. Okay. Oh, is that a stretch? I thought it was a question. All right. Using this graph to the right, on what intervals is g of x? Oh, I got my sticky note. Decreasing. Decreasing is where the graph you're looking at is negative. This is g prime right here. So where is this graph negative? Where to where? Good job. -4 to -2. Union 2.5 to 4. Beautiful. What is the value of g prime of 2? Well, this graph is g prime. So what's your point at 2? 1, do you see that? Please do not overthink that. That's all that that is. This is G prime of 2, 1. Minimum, that is a change from negative to positive. So it's either this one or this one. Where is a change negative to positive? -2. No justifications, that's it. Let's move on. You don't, after you answer a question, you don't want to sit there and mull it over. It's timed. Keep going. You answered it, move on. You have time at the end, you can come back and overthink, all right? Let f be this function. From 1 to 3, is f increasing or decreasing? That comes from your first derivative. Concave up or down, that comes from second derivative. All right, so let's do one thing at a time here. F prime, derivative of 5x. 5 minus, all right, derivative of an integral. It's going to cancel out. You're going to just take the x and plug it in. Now, what was the interval we were looking at? 1 to 3. I would plug in 2. Do you see why I picked that? Okay, so let's plug in 2, see what we get. 5 minus, all right, 2 squared is 4, plus 12, 16, square root of 16 is 4. This comes out to 1. But the point is that it is positive. So that means increasing. We're going to just repeat that process with prime. You're just going to do it again. What's your derivative of your derivative? So derivative of 5, gone. I'm going to cover it up. What's the derivative of square root? I want you to just know this one. Perfect. Only it's going to be negative. Okay, -1/2 square root. There is a chain rule there, though. So chain rule dot, you need to chain on the derivative of the guts of this. So that would be 2x. We're going to plug in 2. Again, why did I pick 2? It's in the interval. I don't really feel like working all that out. The point is it positive or negative? Going to come out negative. So what does that mean? What's your big conclusion since that came out negative? Concave down. Beautiful. I didn't feel like working that out, and I didn't need to. I just needed whether it was positive or negative. I'm going to keep going. You guys can make it. We're nearly there. All right. Decreasing is where your derivative is negative. All right. So let's get our derivative. All you're going to do is take x and plug it in. I need to make some number lines to find where that's negative. We're at the point in the year, are you getting that I'm pulling in stuff from everywhere? I'm like incorporating AP review into all of this, okay? What can you divide out of each of those? 2. Now, I would actually take out -2. And then that's going to split. This is like, welcome back to algebra class here. -4 plus 1. Now, there's 2 ways you can think about this. You can either make a number line for your -2 and just put negatives the whole way through, or you can skip that and just remember your answer is going to be the exact opposite of what you get. So however you think your way through that. Where are we going to have changes for these? Yeah, -1 and 4. And if nothing weird happened, it will be negative, turn positive. So what's your overall sign for the first section? Negative, positive, negative. I forgot what the question was asking for. Decreasing, that would be these 2 sections, the negative sections. So -infinity to -1, union 4 to infinity. You want to?
You already did it, but please, you already did it. Perfect. I will see you next one.
Instead of an infinity. You're going to make it. You're going to be totally okay. I'm still going to finish. Look, with time left over. Yeah.
Like jumping around.
Well, I wanted to do the calculator part first because they're easier. I wanted to start with something inviting,
Yeah.
like where we kind of flew through that page and everybody really, and then you have a good feeling. You get like, yay, I get it.
Yeah.
And then I wanted to knock out the free response. You can take the test in whatever order you want. All right. Almost done, guys. Oh, I guess I should start at the beginning of this page. Continuous function is positive and increasing. Let's go ahead and draw something that's positive and increasing. That means it's above sea level and it's going up. Don't overcomplicate it. I drew something above sea level and headed upwards. Looking at this, where does the accumulation start? 1. So here's 1. And again, you're going to have choices. You won't have to make this up, but I'm going to show you how it shows up with your choices. So here's 1. This is where our accumulation starts. If you make a table of values, if you pick something to the left of 1, like 0, if you accumulate this way, you are going to get a negative number. Do you understand what I'm saying? Okay. Yeah, like you can invent them, but on your test, it might say like -5 or -13 or -4 million. You know what I'm saying? Now, if you have 1, you're going to get 0. You've accumulated precisely nothing. And if you accumulate to the right, so if it says 2 or 3 or whatever, then you're going to get a positive number. So they might put like a 7. There will be choices. You just pick the one that makes sense. Okay. Water is being heated up. We're making our coffee in the morning. Time is in minutes. Temperature is in degrees Fahrenheit. We need an interpretation of what on earth this means. This is what? Initial condition. So that's what the temperature of the water was to start with, like coming out of the tap. Plus, this is like how much you heated it up, the accumulated temperature. So this result, it's what does this mean? Well, that's the temperature at what time? 12 minutes. That is the temperature of your water at 12 minutes. You started with whatever it was when it came out of the tap. You heated it up for 12 minutes. So your result is the temperature at 12 minutes. Please don't overthink that. That's all that means. It's a lot of symbols that mean that. The rate at which students finish their calculus test in students per minute is given by this. How many students finish from 0 to 30? We want an integral from 0 to 30 of that thing. Slice this up and find your areas is what we're doing. You want to do, well, there's a triangle here and then a trapezoid. Okay. So trapezoid, 1/2, what's the height? 10. And then your bases are 10 plus 25. So what is that? 5 times 35. What is that? 175. I would have maybe broken that up smaller. I would have maybe done like a triangle and a square or something, but whatever. All right. And then the other one is 1/2 base times height. So your base is 20 and your height is 25. Half of 20 is 10 times 25 is 250. So if you add those together, 425. Did I add that right in my head? Yeah, 425. At time 0, as our story begins, a particle starts at rest. That means it's not moving. And its acceleration is this. Through how many units does the particle move? This is a little tricky because how far it goes from 0 to 2 needs to be velocity. It's your velocity that goes in there. But what did they give us? But good news, we know how to take an antiderivative, so we can figure it out. Go us, all right? What is our velocity? If you do the antiderivative of this, that'll take you backwards to velocity. I need a function that if I did the derivative, I would get 40t. Perfect. Good job. Now you're going to do another antiderivative. It feels like we just did that. Yeah, you're trying to get from acceleration all the way back to position. So you are going to do it again. I need another antiderivative. 2t to the 5th. And then it's upper minus lower, but you don't really need to plug in 0 because that'll just be 0. So basically just plug in 2. 2 to the 5th is 32 times 2 is 64. It's 2 times 2 times 2. Here, let me walk you through it because I usually just count on my fingers. You ready? 2, 4, 8, 16, 32, 64, 128. Anyway, all right, 2 more. Again, they gave us acceleration for this. Oh, I remember this question. This one's actually not all that hard. It's just they throw a lot of information at you and there's a square root. The position is 8 at time 0, so that's initial, and is 14 at time 1. What's the initial velocity? Okay, well, let's just start trying to write a velocity function, okay? Because they gave us acceleration, we can do an antiderivative. Now, I need to rewrite this. This would be 9t to the what? -1. Good job. Perfect. I love when I don't have to stop what I'm doing and reteach fractions. Perfect that you guys know that. Now we're going to do an antiderivative, which is good because you're going to add 1 and it won't be negative anymore. It'll be positive a half. That means in front of that you would need a 2, but there's already a 9, so 18 plus c. The c is what our goal is. That's your initial velocity. You see what I'm saying? Like our answer to the whole question is what's c. Now we're going to back up again and get our position. So we're going to do it again. If you add 1 to a half, you get 3 halves. In front of that, you would put 2/3, but there is an 18 there. Hold on a second. So we had to do 2/3 times 18. I would do 18 divided by 3 is 6, and then times 2 is 12. However your brain wants to do that. All right, plus, now pretend this was a number, like 7. Your antiderivative would be 7x. This one's t, whatever. If you put x, it's not going to matter. It's multiple choice, so no one will know that you mix and matched your variables. I don't really care. All right, plus 8. Where did I get 8? That's your initial position, okay? And then your last step is you're going to put in 14 for position when time is 1, and then do a little bit of algebra. So you're going to have 14 equals. Oh, and it's great that it's 1, because what's 1 to any power? 1, because you don't want to do to the 3 halves power. Times 12 would be 12, plus just c, because we're plugging in 1 for time, plus 8. So what is c is going to have to be negative, isn't it? -6. Sorry, go ahead. So your antiderivative of c is c times t. Pretend it was a number, like if this was 9, your antiderivative would be 9t. It's just, I don't know what that number is. Well, now I know what it is. It's -6, okay. But all right, last one. Oh, and this one's super easy. I'm going to have you draw a graph here. On your test, the way it's going to look is you're going to have 4 graphs, A, B, C, or D, and it's going to say choose the one where the particle is farthest to the right, or choose the one where the particle is farthest to the left. Okay, here's 5. If you want it to be farthest to the right, that means you need a whole lot of positive accumulation. Do you remember the hot air balloon? I should think of that one. So you need a whole lot of stuff that's above the x-axis. Do you see all this positive accumulation before 5? Now, if you want one farthest to the left, what would you do?
Go the other way?
Well, yeah, instead of above sea level, you would want all your accumulation to be below sea level. So this is farthest to the right. This would be farthest to the left. They're going to give you a selection of graphs and say which one shows farthest to the right. And you pick the one with the most positive area. If they say farthest to the left, pick the one with the most negative area, is all that is.